Hello folks, welcome to the next episode of 5 Minutes Physics GRE. In this episode, we're going to be solving a physics GRE thermodynamics problem in 5 minutes or less. So here's the problem. We have an ideal gas in a container of volume V and temperature T. And there are n molecules of ideal gas inside this box. Now, this box is a piston. And this piston is taken between two thermodynamic states. The piston starts with a volume V1 and then it's decreased, or oops, let me reverse that. The piston starts with a volume V1 and then it's increased to a volume V2. So here's the piston before, okay? And then the piston is extended upwards so that more atoms can occupy this volume inside to this V2. The question we have to answer is quite simple. What is the work done by the ideal gas as the piston expands from volume 1 to volume 2? To answer this question, you need to know something about the equation of state for an ideal gas and about isothermal curves. So here's what you can do. You can draw on the phase diagram, the pressure volume diagram, you can draw the equation of state of the ideal gas. What does that look like? Let me use my color here. As the gas goes from volume 1 to volume 2, its temperature remains constant. What do constant temperature curves look like? They're isothermal curves on the phase diagram. They look like this. Okay? And what are the equations of state of these isothermal curves? These are given by PV to the gamma is constant. So let me choose one of these isothermal curves to represent the change in state of our ideal gas. So if this curve, this isothermal curve represents the change in state of our ideal gas, then how can we use this to calculate the work done by our gas? Well, let's say our gas starts at this point A and ends at this point B, starting from an initial pressure P1, ending with a final pressure P2, starting with a volume V1, ending with a volume V2. So now, the next thing we have to do is exploit the ideal gas law. The ideal gas law is the equation of state for an ideal gas. And that says that PV is NKT. Now, how's that going to help us? Well, we know that the work done by a gas, dW, is simply P dV. But we also know from the ideal gas law what P is. The pressure in the ideal gas law can be expressed in terms of the number of particles, temperature, and the volume. So that means the pressure is NKT over V, right? And so we can substitute that in here so that dW is NKT over V dV. And so now we simply have to integrate both sides with respect to their corresponding variables. And we're going to integrate from the initial volume V1 to the final volume V2, V1 to V2. So that is going to give us the total work done by this ideal gas is as follows. Just integrate this. We get NKT times the natural log of the volume from V1 to V2, so that the total work done by the ideal gas is NKT times the natural log of V2 over V1. All right, that's how you answer this physics GRE problem. Thank you for watching, folks, and if you have any questions, put them in the comments below. We'll see you.